All right, guys, here we go. Section 3 for Chapter 1. We are looking at a couple formulas here. We're going to look at our distance formula and our midpoint formula. So not a ton to them other than it's just a matter of plugging in the numbers and simplifying it correctly. So I want to start out real quick with just a super basic distance on a number line and how this is slightly different than this guy for finding distance between 2 points. So typically on a number line, when it is just straight over on that line, you can just count the spaces, right? So I could say from A to B is 1, 2, 3, 4, 5 units, right? So we would say the distance of AB is, or the length of AB is 5. So what if you are traveling at an angle though? So if I'm traveling at an angle instead of straight over on a line, it's a little different because I can't count at an angle. There's no specific values or units to count by, right? And so that's where we're going to need a different formula that's going to help us out with that. So anytime, let me just mention this, but anytime you are ever going horizontal or vertical, you can just count the length. Right? But anytime you're traveling at an angle, you need to use your distance formula. So here's our distance formula. We are going to find the difference in the x's, and we're going to find the difference in the y's, and the rest is simplifying. So think of this as your first x and y. So whenever you see x with a little 1 right here, we call that x sub 1 or y sub 1. All that means is that's my first x, and that's my first y. Right? So they're calling A the first point, and then B is the second point. It's x2 and y2. So my second x and my second y. Keep in mind, it really doesn't matter whether this was x1 and y1 or if this one was x1 and y1, it would not matter. As long as your 1s are together and your 2s are together, it doesn't matter which you want to call, either one. So for something like this, if we wanted to find just say the distance between 2 points. And let me go down to these guys. All right, so let me start with the easy one. So just a basic number line. These are ones we can simply count the difference, right? So if I was starting from A and I was traveling to B, I could simply go, I'm 1, 2, 3, 4, 5, 6 units away. So AB is 6. We could use what if they were super far away, right? What if this was like -50 and this was +30, right? You don't want to count that far. So you could do some basic algebra on that as well and just subtract or find the difference in their values. You can see A is -4. You can see B is +2. And so we are going to simply find the difference between -4 and +2. So we're going to do -4 minus +2. And just find their difference. So these guys have a difference of -6. So why the absolute values, right? Why don't we say the length of AB is -6? Why not say it's, why not say it's -6? Why do we have to say it's +6? Length can never be negative, right? When we say the length of something, you're never going to say the length of that box is -6 feet. Right? It's never negative. Length is always described as a positive. So if you do it this way, well, we want to make sure that we describe our answer always as a positive. Here's how our distance formula works. Again, here's my 2 points. We're going to call this one our, this can be x1 and y1. Or if you want, this one could be x1 and y1. It doesn't really matter. Right here we are putting the difference in the x's. So my x's are 1 and -2. So those guys are going in for those. And so we're finding the difference between 1 and -2. And then over here we're going to put the y values. So the 3 and the -1 are going into this formula. And we're going to find their difference. So it's always subtraction in between those numbers. And then we're just going to do a little cleanup. So remember your order of operations. Parentheses first. So we did 1 minus -2 first. And that gave us our 3. 3 minus -1 would be 4. Next you would do exponents. So 3 squared would be 9. 4 squared would be 16. Then we would add those together. Right? It's still under a radical. So what is the square root of 25? Right, it would be 5. If this was not a perfect square, that's something we're going to be working with more and more, but we can leave it in radical form. I would only tell you to put it into a calculator and get a decimal if the direction specifically said, like, round your answer to the nearest tenth or something like that, right? But if it doesn't say, it's probably best to leave it in just a radical form if you can't simplify it any further, right? So if I had something like the square root of 40, right? 40 is obviously not a perfect square. If the direction said, round your answer to the nearest tenth, well, then I would go into my calculator and we would do the square root of 40, and I would say my answer is 6.3. But if it didn't say that, and it wants us to leave our answer in radical form, this wasn't really going to be a part of this lesson, but I'm just going to mention it because I think we all need practice on these. How do we simplify a radical? This is something you would have learned in Algebra 1, but let me give you a reminder. Some of you might have used factor trees. I can do that, but let me show you sort of a different way first. When I look at something like the square root of 40, even though 40 is not a perfect square, I want to find the biggest perfect square that is a part of 40, right? So what I would see this as is simply 4 times 10, right, which is still 40, but 4 is a perfect square, right? And so that can be simplified. I know the square root of 4 is 2. And the guy that's not a perfect square, we just leave under the radical, right? And so that's my way of doing it. Some of you guys might have done the whole factor tree where you said, okay, how can I break down 40? We can do 4 times 10. I can do 2 times 2 times 2 times 5. So there's nothing wrong with this. It just gets a little tedious, especially with bigger numbers. When you did this, when you would have learned this, you would have said, well, anything that has a pair, because it's a square root, if it has a partner, then that's the number that gets to leave the radical. Anything that does not have a partner, like 2 times 5, is what has to stay under the radical. So you could do it that way too. Just something we're going to work on throughout the year. So here's a good place for you guys to pause if you would like and try these on your own before I do them. But here we go. So use the number line to find each measure. So if we were to look at AF, so these are just number line problems. So here's A, here's F. Again, I could count them and see how many spaces apart they are. But let's try the algebra. Right? You can see A is at -9. I can see that F is at 3. And so I want to find their difference. So I'm going to put a minus between them. That would be -12. And like we talked about earlier, we never have a negative length. So instead of leaving my answer as -12, we're going to change it to a positive. So from D to G, again, you can see D is at 1. G is at 8. So 1 and 8, I'm going to find their difference to get the length, which is -7, which we would turn into a positive. So 7 units for the length of DG. Find the distance between each pair of points. Okay, so now we are no longer going from left to right or bottom to top. These guys would go at an angle, okay, if we were to do that. So we're going to throw those into our distance formula, which is all under this big radical. So I'm going to find the difference in my x's, so the 6 and the 0. I'm going to find the difference in my y's, which are 8 and 0. And then we're just going to do a little cleanup on that. So 6 minus 0, of course, is 6. Squared is 36. 8 squared is 64. When I bring those together, they total 100. And of course, the square root of 100 is 10. So that would be our distance between A and B, or you could say the length of AB. Same thing. One more over here. So again, I'm going to do the difference in my x's. So -4 minus -2. I'm going to find the difference in my y values, which are 3 and 10. So that would work as our setup. And let's simplify. So parentheses first, double negative. So this is negative 4 plus 2, which is negative 2. And negative 2 squared would be 4. Remember, you square a negative and it does become positive, since negative 2 times negative 2 is 4. Their difference is 7, negative 7, but negative 7 squared would be 49. So that would work as our answer. If the directions said write your answer to the nearest tenth, I would type that into a calculator. If it doesn't, go ahead and leave it as a radical. And this one cannot be simplified. If you were to try to do a factor tree on it like I did up here, you would find that it cannot be broken down. 53 is a prime number, so that's as far as it goes. So let me flip. So our midpoint is super simple. So up here at the top, you're going to see our formula for a midpoint, right? That's this one up here. So this is our midpoint. So just like the name would suggest, a midpoint is a point. So we write it as an ordered pair. So the midpoint consists of an x coordinate and a y coordinate. And all we have to do on that is it's just like finding an average. You add up the x's and divide by 2. And that gives you the x coordinate. Add up your y's and divide by 2, and you get your y coordinate. So the first way you're going to see this is like, so how would this look in its like most basic, simplest form? So if I go back to our basic number line, and I said, what is the midpoint of PQ? On a number line, that's just like saying what number is smack dab in the middle between P and Q, right? And you can see right here, obviously negative 1 is in the middle. If I wasn't sure, I could take my points, add them up, and divide by 2, right? Like finding their average, right? And so if I simplify that, we can see that negative 1 is in the middle. So let's do it with ones that are a little more complicated though. So what if these are my points, right? So my x's are negative 2 and positive 4. So those are going in for these guys. So here's my setup for finding the middle for the x's. And then for the y values, which are 4 and 1, those ones are going right here. So that's our setup. And if you simplify that, this is our midpoint. So I keep my x's right here. I keep my y values second, and we write it as an ordered pair. So if you want to try, these are going to be our last 3. So if you want to try any of these on your own before I do the video here, you can pause. So we're going to find the middle, the midpoint of CE. So here's C and E. It goes from negative 4 to 2. So if I want the middle, I'm going to find the average, which is to add them and divide by 2. So if I clean that up, negative 2 over 2 is negative 1. All right, so that's just the basic number line. With a set of points, let's try it with these guys. So number 2 is simpler. I'm going to add my x's and divide by 2. Over here, I'm going to add my y values and divide by 2. And so that's what my setup would look like, and I really hope you guys show your work in your homework. This is what the work should look like. If I clean this up, 12 over 2 is 6. 8 over 2 is 4. So this would be the midpoint of AB. And let's do one more with RS. I'm going to add my x's and divide by 2. I'm going to add my y values and divide by 2. So that's what our setup would look like. A little simplifying here, negative 12 plus 6 is negative 6 divided by 2. And 15 over 2, which you could leave as 15 over 2. That would be totally fine, since that does not reduce. If you wanted to write it as a decimal, totally fine as well. Either way would be good. So when you're doing homework, again, just make sure you show work. That's super important in all math, of course. So please do that. But that is it for now.